This question is from the 2016 higher level DCG paper, and it's the structural forms question in section C of the paper. It's question C2. The image on the right shows a low energy building which is built in Abu Dhabi. Its architectural design includes a series of supporting towers. Each tower is based on half a hyperbolide of revolution with a truncated cylinder on top as shown. So the top portion from the middle there is based on a truncated cylinder or cut cylinder. Figure C2 below shows the plan elevation and end view of one of the towers. A pictorial view is also given. Part A, draw the given plan of the tower and project the elevation as shown. Okay, scale 1 is to 100 there, so divide every measurement by 100. Now, full plan view is diameter 12, which is 120. So I'm going to make sure I have room for that. Right there, full height then is 13. Make sure the space. Okay, that should be fine. Right, XY line across the page. Center axis then going down the middle. And the diameter of the big circle there is 12 meters. So I'll leave a gap of about 5 will be fine. And then 12, so that'll be 60 millimeters down. Draw my center axis across. Now, draw in that radius 60. Okay, and then the throat circle in this case, they tell us is diameter 5 meters, which is 50. So diameter, so that's radius 25. Okay, so drawing your throat circle there as well. Now, once you've got those two, you can bring them up to front elevation. So I'm going to bring up the outside of the big circle up to the XY line. And the middle one is up a distance of 100. So it's only half of the hyperbolide revolution that we're drawing here. Draw a construction line across and bring up the two sides of the throat circle then. Now, I'm going to use the asymptote method for this. So I'm going to draw a line tangent to the throat circle till it touches the outer edges of the big circle there. And then if we bring up the ends of the line where it touches the big circle, that gives me that point in front elevation and that point. And they're the 2 points needed now to draw in that X or that asymptote X in front elevation. Now it's not going to be an X this time, it's only going to be a V because it's only going to the center and we only need half. So we don't need to draw the full thing there. Now, once we've got that, we can find our slopes now on each side here in front elevation. So first thing I'm going to do is that line that I did as a tangent there, I'm going to divide it up into 4 different spaces. Now they don't have to be even, you can just plot 4 different spaces on it, and I'm going to label them 1 to 4. 1, 2, 3 and 4. Each one of those points now will come up to the asymptote line, which is there, and then come straight across. And then in plan view, I'm going to swing it around at the center point, set my compass to 1, swing up to the horizontal line, and then bring it straight up to the front elevation, to where it crossed that line that I brought across. Okay, same for each one of the points now. So bring 2 straight up, where it crosses the asymptote line, bring your line across. Set your compass from the center to 2, scribe a line up to horizontal, and bring it straight up to the front elevation. Okay, same for 3 and 4. was 3, and that one there was point number 4. And then it joins back to the very outer edge there at the bottom. So I can then draw in that curve just by joining the points. Left hand side then will just be a mirror image across, so I can mirror each one of the points over to the left. And same as the right, just join the points then. Okay, that's front elevation and plan view of the Hyperbolite of Revolution part drawn in. Now, we have a couple of more things to draw here. Next thing we want to find now is this triangular opening, which is not part of the end view. Okay, yeah. So, triangle opening, it tells us here that it's diameter 5 for the circle there, which looks to run through those 2 points as well. So if I bring those 2 points down to the bottom, that gives me 2 points on the bottom edge there. And then we're told that this top section is divided up into 5 equal spaces, and that point hits line 3 up there from the bottom. So if we were to divide that into 5 equal spaces, going up to the center point there, the whole thing is 100. So each one would be at 2, 4, 6, and 8. Draw them as lines going across to both sides. I try and don't get them confused with the lines from before. There, and we're told that the V goes up to that point in front elevation. Okay, and we know that it goes to those points there, which is that one and that one. And we can draw them as straight lines now in front elevation. Okay, so that's the V found. Now, to get the points here, we bring each one across to the edge, drop it down to the horizontal line, and swing it around then in plan. Swing it around in plan, it's going to give me that line there, or that point. So I can draw in now that V shape. It's 2 straight lines in this view as well. Okay, so that's the plan view finished, and front elevation almost finished, just the truncated cylinder bit on the top there. So told it goes up a height of 3 meters, which is 30. Just draw that line across the page because I need it for my end view later as well. And the one on the right hand side goes up a 90-degree angle. And the other side slopes down to there. Okay, that's front elevation and plan view finished. Now, next part of the question. Part B, project an end view of the tower as shown. Okay, so we can bring over our center point. That's the center axis there, so I'm going to bring that up now at 45 degrees. Bring that straight up. Now, the top portion, this is a sliced cylinder, so that top portion has to be based on an ellipse. So I know that point is the center of my ellipse. That line there must be the bottom. And the major axis and minor axis. Major axis would be the full distance across. okay, or that distance there. So major axis would be that one. And minor axis would be from the center point to the top there. So we're back to conic sections now, drawing a basic ellipse. Okay, 2 circles, keep it light for construction. Divide up with your 30/60 set square, same as usual. And then lines come down from the major axis, a major circle, and then across from the minor. And then you just match up the points. Okay, so that's your ellipse now in the end elevation. So we can continue with it now. I'm going to bring across each one of the lines now. So it's probably best if I use the cut lines that I had drawn in there that they have given in the question. So I'll bring each one of those across. Okay. That one goes straight down because that's the cylindrical part there at the top. And then each one of these will be the exact same. Because it's a circular profile, we can just draw in the circular part there again. There's a little bit for the opening there on the side, but we'll get the basic outline here to begin with. So I'm going to match these points. That's the distance across there. Match that now on this one. We're just looking at it from a different side, so the shape remains the same. Same out to there. And bottom one, distance out as well. And the very bottom one should follow out from those points. Okay, so that gives me the bottom point and the bottom point there. Now if I join those dots on that side, that's one's left hand side finished. This side up until the opening there will continue down the very same. Now it gets a little bit different here because we have the V opening there. So instead of going the whole way out to there, it's only going to go to in line with these two. So that will be the bottom point. Now you can just about see it there. So where it hits in line with these two, bring it over to the side line there and bring it up. That gives me this point. So instead of going out to the very end, it's only going to go to this point here. And to get where it goes out for each one, we need to bring them across. So that point there in that view gives me that point in plan, and same with that one. So there are the outer edges. If we bring those across now and up to the end elevation, that will get the proper or the true side profile or end view of the object because of that cut section there at the front. So it should be in a little bit further. It's almost in the same line there for that one, and that one there cuts in a little bit further. Now, I'm not sure, it should be a straight line going between them, or close to straight down to that point there at the bottom. So the right hand side is a little bit different because of that cut section there that we were given. Okay, that's part B of the question finished. Part C then, determine the positions of the focal point and the directrix for one branch on the hyperbola in the elevation. Okay, so to get that, same method as usual for this. Draw your sphere inside your double hyperbola there with a center point on the point where the asymptotes cross, and just draw your circle there at the top. So it fits in neatly there. And then the directrix, it only asks for one of the branches, is where the asymptote hits that circle. So that line there would be your directrix. You could do it on either side, it doesn't matter. Label it D and D for that parabola. And to get the focal point, you go perpendicular from the asymptote to where it hits that circle that we've drawn in. So perpendicular there, that gets F on that line, and now you find the focal point and the directrix. Determine the positions of the focal point and directrix for the branch. You're not asked for the vertex. If you were, that would be the vertex there as well. Okay, and that's your full question complete.